All right, so section 5.1 is the angles of triangles. Recall that a triangle is a polygon with three sides. You can classify triangles by sides or angles. If we do it by sides, if it's scalene, it has no congruent sides. Isosceles has at least two congruent sides, and you can tell because they are tick marked. And an equilateral triangle has three congruent sides. And again, this time they tick marked it by two. If we classify them by angles, an acute triangle, has three acute angles. Remember, I told you they're small. Think, oh, what a cute little angle. A right triangle, has one right angle. And again, if one of them's right, then you know that the other two have to add up to 90 degrees because right angle is 90 degrees. So that means that the other two also have to be acute angles. An obtuse triangle has one obtuse angle. So remember, that's one that's greater than 90, yet less than 180. And of course, we can have an equal angular triangle, which would also mean it'd be equilateral because it would have three congruent angles, and all three of them would be 60 degrees in this case. So example 1, it says classify the triangular shape of the support beams in the diagram by the sides and by measuring its angles. So on this one here, you can see it here pretty good, but if you run this off on your printer, you wouldn't see it. So it's right here. There's the triangle that they're talking about. Okay, so if you look at it there, all right, you can kind of see that it has a right angle. Okay, and if you look at it, you should realize that it has no tick marks. All right, so like I just said, let's look at the sides. And just like I said, there's no tick marks. Since there are no tick marks, that means there's no congruent sides. And if there are no congruent sides, that means that it's a scalene triangle. Okay, now look at the angles. If we were in class, I would have you measure them, and you would notice that you would use a protractor. But right now, since we're not in class, just kind of look at it and say, look at what you see. So you see a right angle. Okay. And then if there's one right angle, that means that we're going to have a right triangle. So our answer that we have is a scalene, which talks about the sides, right, which talks about the angles, and it's a triangle. Okay? All right. Number 2, classify triangle ABC by its sides, then determine whether it is a right angle. So hopefully I left myself enough room on this one here. So step 1, and let's go with a different color. And I'll write smaller. So find the lengths. Of all three sides. Okay. And to do that, we would use the distance formula. And again, remember the distance formula is d is equal to the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. All right. So if we look at the first one, AB, so if I said AB, I'm going to say this one here is, tell you they put that in the wrong place for me. This one here is going to be x1, y1. This one here will be x2, y2. So if I use AB, I'm going to say it's the square root of 7 minus 0 squared plus 1 minus 3 squared. If I work that out, 7 minus 0 squared is 7 squared, which is 49. 1 minus 3 is negative 2. Negative 2 squared is 4, so we'll get the square root of 49 plus 4, which is the square root of 53. To me, if we're just looking at the length of the sides, I would say you could leave it right there, but the book went ahead and went to the nearest tenth, so it would be 7.3. All right, now I'm going to do, let's do AC. Remember, I'm not putting a line over it because that would be talking about the line segment. So on that one there, I'm going to call this one, again, let's still call this one x1, y1. This one here, x2, y2. And in this case, I would have 1 minus 0 squared plus negative 1 minus 3 squared. And in that one there, I'll get, I'm just going to go ahead and add it up for you right now. And again, it would be approximately 4.1. And then the last one that we have to do is BC. And if I do BC, and again, let's see here. I'm going to call this one here, what did I call it? This one here I'm going to call x1, y1. This one here, x2, y2. So then I'll have 7 minus 1 quantity squared plus negative 1 minus 1 squared. Again, if you work that one out, you'll get the square root of 40. So as you can see, even underneath the radical signs, each one is different. To me, that would have been okay. If they would have been, two of them had the same under the radical, I would have been okay with that. All right. So as we can see, there's no congruent sides. So let's see. So if you remember from above when I said there's no congruent sides, that means that we have a scalene triangle. So ABC is a scalene, at least that's the part with the sides. So now we still have to look at the angles. All right, so I have to see if there are any right angles. So step 2. Find the slopes of each side. Okay. Remember, the slope is just simply y2 minus y1 over x2 minus x1. All right, so I'm going to take the slope of the first one, so I'm going to call it the slope of AB. And if I take that one there, I'm going to take 1 minus 3 over 7 minus 0, which will give me negative 2 over 7. The slope of AC, if I take that one again, I'm going to take negative 1 minus 3 over 1 minus 0, which will be a negative 4 over 1, or just negative 4. And then finally, the last one, I will take the slope of BC. So on here, my M means my slope. My BC is the line segment I'm talking about. On that one there, I'll have negative 1 over minus 1 over 1 minus 7, which is negative 2 over 6, or negative 6, excuse me. And remember, you should always reduce. So that'll reduce to 1/3 because a negative divided by negative is a positive, right? So we can conclude that no two slopes have a product of negative 1, because remember, if they have a product that equals negative 1, then we know they're perpendicular. So since we don't have that, we can say no sides are perpendicular to each other. And so there's no right angles. And so on this one here, we would find out that if we measured them, but again, I'm not going to make you do something that you can't do yet. And I think on the homework, you'll be okay. So on this here, we would say then that we have our triangle ABC is an acute. Because now we're putting it all together. So it's an acute scaling triangle. And look, I barely had enough room there. All right, so remember, when they're classifying them, you classify by the sides and the angles. All right, so now we're going to talk about some theorems here. We're not going to have you do any theorems right now either. So I would say yay if I was you. Yay. All right, so let's see. So the triangle sum theorem states that the sum of the measures of the interior angles of a triangle is 180 degrees. So what they're saying is the interior, that means the inside of the triangle. So that would be all of those. And since we're talking about measure, remember when we're talking about measure, we're going to say M, the measure of angle A, plus the measure of angle B, plus the measure of angle C is equal to 180. That is what that theorem is stating to us. It's that simple. Okay. Now, when the sides of a polygon are extended, the angles outside are called exterior angles. So the interior ones, you can see they're in there. So on this one right here, what it is saying is that this one here is an exterior angle. Okay, so this here one would be an adjacent, because remember, adjacent means next to. We talked about that earlier. So adjacent, and since it's on the inside, it's an adjacent interior. And then this one here, since we're talking about this angle here, these two here, they're not next to it, so they're not adjacent. Interior angles. Okay, so it says the measure of an exterior angle of a triangle, so that would be this angle 1 here, is equal to the sum of the measures of the two non-adjacent, so that means the ones farthest away from the outside one, interior angles. So what this states here is that we can say that the measure of angle 1 is equal to the measure of angle A plus the measure of angle B. Remember, each one of those we can call that because they're not intersecting lines. Remember, I talked to you about that too. So, all right. So, example 3: find the measure of angle PQS. So they want us to find the measure of this angle here. So that is our exterior angle, and we know it is equal to the sum of the two interior angles, the non-adjacent ones. So we can say that 3x plus 25 is equal to the sum of these two. So that would be 2x plus 65 degrees. Okay, so now let's go ahead. We'll subtract 2x. So I'll get x, all right, plus 25 is equal to 65. And then I'm going to subtract the 25. And I'll get that x is equal to 40. So now we're going to substitute. $40 for x and 3x plus 25 to find the measure of angle PQS. So I'll say that the measure of angle PQS is equal to 3 times 40 plus 25, which is equal to 120 plus 25, which is equal to 145 degrees. And remember, we can't always base it on what we see, but we should notice that that is an obtuse angle, right? So we should be okay saying that, okay? And then finally, those were theorems. Remember, I kept telling you we're going to keep looking at these theorems. And I just want you to remember, corollary to a theorem is a statement that can easily be proved using the theorem. Again, we're not going to use proofs right now, but I'm just telling you that it means the same thing. So the acute angles of a right triangle are complementary. Well, that should make sense here, right? Because if angle C is our right angle, then we know that these two here also have to just equal 90 degrees. So remember, the definition of complementary is 90 degrees. So that tells us that the measure of angle A plus the measure of angle B is equal to 90 degrees. All right, so now why am I telling you that? Well, I did have a proof on there, but I've gotten rid of it. So, but we do need it for word problems like the following. The measure of one acute angle of a right triangle, is 1.5 times the measure of the other acute angle. Find the measure of each acute angle. All right. So if they don't give you a drawing, ladies and gentlemen, draw a picture if it helps you. So if I draw this picture here, and I'm going to say this one's my right angle. All right. If that's the case, then it says the measure of one of my acute angles is 1.5 times the measure of the other one. So if I let this one here equal x degrees, then this one here is 1.5 times x degrees. All right. So what do we know about those two there? We know that according to the corollary we just talked about, 1.5x plus x is equal to 90 degrees. So if we add those up, 1.5 plus 1 is 2.5x is equal to 90 degrees. To get x by itself, I'm going to divide both sides by 2.5. And then that'll give me that x is equal to 36 degrees. Now that's only this one here. So again, don't lose a point, ladies and gentlemen, for not following the directions. It said find the measure of each acute angle. So the other one is 1.5x. Well, we just said x was 36 degrees. And if we do that, we find out that it's 54 degrees. And as a quick check, ladies and gentlemen, does 36 plus 54 equal 90? Of course it does. So that's it. We're done.